There we go. Hello. Hello and welcome to all my combo lords. Finally got that going. I guess maybe there was a little glitch at the beginning of me talking about it going. Maybe I'll trim that for the future viewers. Right now, it looks like the rain has picked back up. We're streaming at a kind of unconventional time for me. Right now, it's 6:20 a.m. And usually I stream when it's my later morning or evening. But I was up early and I thought it was going to be a little break from the rain, but apparently the rain has returned. But I think we have shelter here on the porch. When it rains really heavily, sometimes it can be a problem having anything on the porch. The wind will fly the rain and ricochet the rain and get everything that is on the porch wet. But I think this level of rain, for the amount of time it might go for a minute, hopefully won't start splashing. If it does, we'll have to relocate to my room before the sunrise. The goal is to hang out here, watch the sun come up, maybe have a little rain splash on us, but hopefully not the computer. And then we can pop inside to look at a few morning integer sequences or graphs. I've been getting up probably too early, not in terms of that you shouldn't get up at 5 or 6 a.m., but I go to bed kind of late and get up early. I need to work on my sleep schedule still. But when I'm up early, sometimes I gotta recalibrate my mind and think, okay, we gotta set up for a good, excited day. We gotta tap into the good Demotro. Let me move this a little closer. We're getting a little splashing action on the computer. We're gonna have to be careful here. The computer is now like right on the center of the porch, maybe the least splashable zone. Now, the rain is going to go pretty crazy today. I see in the forecast they have lightning symbols, and across the Bay Area where I am, there's actually pretty bad flooding and stuff. So, we don't live right next to a river or anything, but all the places near the Bay Area of California that are next to a river are in trouble. They are evacuating, a lot of problems and stuff. Right here, we get more minor trouble, which is like power outages sometimes, which hasn't hit me this time, but could happen over the week, and the yard flooding. So luckily we have a crawl space under the house and not a basement, so it's not flooding a basement because we don't have one, but it still causes this massive puddle. You guys have probably seen the lake in the combo classroom. And right now the lake drained because yesterday it wasn't raining as much. But right back there, there's like a huge puddle slash mini lake that if the sunrise comes up and we're still hanging out here, maybe I'll be able to point the camera and show you how if you hang out over in that part of the yard, you're hanging out in a puddle. And hello to everyone who's in different time zones. Cool to pop over and say where you're at. Very interesting. I knew that although I was saying let's watch the sunrise, that most of my viewers wouldn't be in my time zone right now. More people are going to be watching this in some other part of the globe at a more regular time of day than watching it near me at 6:20 a.m. But I was up early, so I figured let's do a little live video. My goal on some of these live streams is going to be to make the first 10 or 20 minutes some topic I have a plan for, and then that will be something that if you miss the live stream, you can always watch it later, get a little free video, and then I'll probably get distracted from the topic and move on to random graphs or equations or answering comments or stories from my past or whatever. And today's topic isn't really starting with a math one, although we will look at some math stuff when we have to go back to my room. What we're starting with today is an appreciation of the sunrise and the rain, trying to enjoy the rain. It's hard sometimes to enjoy forces of nature that are more powerful than you. If the rain is this force of nature that it decides what your day is going to be like and you have no say over it, it's this bigger force of nature you got to contend with. But there's a way to make peace with it and have an alliance with it. So although me and the rain have had wars in the past, or battles more like, I've formed an alliance with the rain. It has unintentionally become one of the recurring symbols of grade -1, along with the other three classic of the four elements, though air and earth and fire, which were slightly more intentionally placed as symbols in the grade, the rain kind of decided that the water was going to be a symbol of the grade too. That's okay, because all four elements are cool. I will forge an alliance with the rain. And yeah, I'm going to have to dust off the camera every once in a while. It's getting a little, like, tiny water dust on the computer, so we're not going to be able to hang out here too long. Hopefully we can watch the sunrise, because I think it'll come up pretty soon. And yeah, everyone's in radically different time zones in these comments. That is pretty awesome. Someone asked real quick what I think about lost media. If they mean like, that could mean a lot of things. If you mean where there's like some obscure show or episode of a show that's hard to track down and has some strange trait about it that's worth digging up, I think that's interesting. There's actually a lot of random media that I've wanted to make commentary on before that I don't put on here because I don't want to get this channel copyright struck ever. Like, my two YouTube channels are like my babies, and I would, I really don't want to get YouTube mad at these two channels. So I might, when I do launch like a streaming schedule pretty soon and have a few steady days where I'm always streaming each week on YouTube, I might do a few days on Twitch also, where a lot of other people stream. I don't really use that myself, but I think it might be fun to stream on there sometimes to care less about what I show on screen. I wouldn't care that much if they like ended up taking down the Combo Class Twitch page or whatever. So then I could make more random commentaries on lost media-esque things. And yeah, this is rain in the back. It's getting louder now. Let's also look at this angle for a second where right on the edge of the porch, you get extra. I guess you see it there too. So the rain looks extra from certain angles because it's falling right off the edge of surface. Okay. All right. That's rain. Okay. We might have to relocate inside soon because the computer is getting a little splashed by all this. And computers don't really like splashes. Let's hang out here for 1 second and see if it chills out. Okay. It's chilling out. Okay, I'm hoping we can hang out for the sunrise, but if it keeps raining like that, my computer's going to be at too much of a splash risk and we're going to have to move inside earlier. I don't care if I get wet. I care if my computer gets wet. So, looks like it chilled out a little bit. So, cool. Lots of nice comments. Thank you all for leaving your thoughts and everything. Some of the stuff we're going to look at today, in addition to our little sunrise appreciation, is going to be some sequences on the OEIS, the Online Encyclopedia of Integer Sequences. I found a new feature on that app that's going to be a staple of our streams going forward. There's a few things that I've really enjoyed in the stream that I think I will do on a recurring basis, one of which is making crazy shapes on Desmos from simple graphs. Another of which is asking that chat robot about numbers and seeing how ridiculously dumb it is about numbers. And another of which I think will be this new feature on the OEIS that I'll show when we have to go back to my room. Then we also will probably look at a few crazy Desmos shapes because, as usual, I have fiddled around on the graphing calculator in the meantime and found a few new variations that I think you'll enjoy. And yeah, asking the rain some questions. We could try and get some calculations from the rain sometime. Maybe we could try and use it as a random number generator. You know, if we, could be an interesting thought. I do want to hear suggestions over time of ways in which I can incorporate the nature into experiments that give us details about the numbers. Always fun when we can do that sort of combo, as you may say, between the natural side of me and the math side of me. I was thinking this morning when I got up about how I was like, okay, I'm going to do a stream that's called Let's Watch the Sunrise and then look at some integer sequences. And I was like, I don't think that many channels do that combo. I feel like most of the math channels are like indoors on some whiteboard or on their computer all the time. There's not enough math channels or education. I don't want to be branded as a math channel because that's just what I'm addicted to doing this year, but I like a lot of topics. But I'm a somewhat math-centric channel, and I don't think that many math channels like nature enough. They need to be out doing it in the wild, and the nature automatically brings the chaos. So, you know how you associate some chaos with the combo class because there's always things shattering or burning or whatever. Well, some of the chaos is just the nature. It helps me out with that aspect. I don't even need to add chaos when it's, slippery enough in the mud and everything's breaking from the rain and birds are flying around. And so I think that we're definitely going to, now that my legs have mostly recovered from some surgeries I had to get, although, like, I still have a doctor appointment after this stream. I'm still in the middle of a lot of medical things that are hard for me. I'm able to walk again, and so we're going to do more voyages into nature. I'm going to have some days where I pay a camera person a little extra and have them help me trek out some whiteboards to, like, a river or a forest or something. That would be a good vibe. Whiteboard by the river. I feel like that's very underutilized. In fact, a stream by a river would be amazing, because if I ever didn't have anything to talk about, the river does the art for me. Rivers are always moving and evolving in front of your eyes. Same with forests in general. A stream in a forest, I could talk a lot less and it would still be a better stream because the nature talks for you. I probably would interrupt it though because I like talking. So let's see what else we have in the comments here. Lots of good thoughts. And the universe is infamous for chaos, and math certainly crosses over to chaos, and nature crosses over to order. But I think that inherently math is more on the side of order, and nature is more on the side of chaos, at least in the way that they feel in my personal life. Nature has many different types, so does math. Sometimes it's one and the same, like when we look at our Desmos graphs and they look like flowers and eyes, and it's like, okay, well, the sine curve generated this shape, and natural selection generated this shape through evolution. Maybe they're one and the same. And yeah, Fibonacci sequences in plants. The thing is that some of those are overrated. Not as many plants has the Fibonacci sequence as some people think. However, the Fibonacci sequence isn't underrated. It's mathematically glorious. And so the golden ratio, even more so, is mathematically glorious, which is similar to a Fibonacci-esque sequence where each term is the last two added. But even if you don't feed it in 0 and 1 or 1 and 1 as your first ones, the Fibonacci-esque sequence will converge to a rate of growth of the golden ratio. So the Fibonacci sequence and golden ratio are mathematically glorious. They're in a few less plants than some people think, though. I will try and look for it. They are in some sunflowers, so I can look for it in that and some other plants. The Fibonacci sequence, more so than being in how many leaves a plant has, can actually be in rates of growth. So I can, I might not be able to observe this, but we could make analogies about populations of animals or plants growing, and those would relate to the golden ratio, or depending on the rate of growth, may relate to the number E. Also pops up in a lot of rate of growths. And yeah, to everyone leaving a lot of the same comment, remember that I'm pretty chill on moderating. It's very rare that I remove comments, but don't spam stuff too much or I will have to put you out of the chat, or, we need a lot of different fun thoughts. We like variety in the combo class. It's good to recur a thought over different streams. You can leave the same thought once on every single stream I leave if you want, but maybe not 10 times on the same stream. Variation is good, and that's something that's fun about chatting with my combo lords. And to anyone who likes chatting with a variety of people, remember we do have a Discord with a bunch of people and a subreddit that should get more posts. I'm going to make some more threads on there. And so those are good places to chat. Also, of course, got to mention that any super helpful combo lords can check out the Patreon, where I frequently post bonus stuff and also some opportunities to talk to me more directly. And yeah, a lot of other good suggestions too of things like we could measure sunrises or we could measure shadows and angles for the sun. That's one that I've definitely thought of. Is we'll have a lot of clock-based episodes in the future, and the cool thing about clocks is we can take it in a more mathematical direction and be like, oh, this clock represents mod 6 or whatever. Or we could take a clock in a more engineering direction and actually not be thinking about a circular clock-like shape, but be thinking about the idea of trying to keep track of time. And one experiment I want to do is I read that one type of old-fashioned alarm clock was you'd have a candle and you'd put nails in the candle, and as you'd have a tin pan or like metal pan under it, and as it melted to a certain point, a nail would fall and hit the metal pan and make a little clanging noise. And that would be your alarm clock. And I want to test that. I want to melt a candle with a nail in it, hear a little ting when it hits the thing, and then see how long that took, and see if I can make a candle that actually times a given amount of time. Like, can I make an alarm clock? How close can I make an alarm clock to counting 10 minutes? And we might have ones that relate to sand or water or candles or stuff like that. So that'd be a really fun version, is making old-fashioned alarm clocks, which, funny enough, is a completely just other side of me liking clocks. That's like, it's also fun to try and make something that keeps track of 10 minutes somehow, which is kind of different than my obsession of clock-like things, which will also recur not only in math, but in our music theory lessons we're going to do in not that long. Might not be in grade -1, but I have some really cool music theory lessons to put out in either like late grade -1 or early grade -2. And those even relate to clock-like wheels. And yeah, whoever mentioned the continuum hypothesis, I haven't gone into that in this channel yet, but very strange. Being independent, as they say, means there's this very strange thing called the continuum hypothesis that, whether it's true or not, can fit into certain common ways of making axioms for systems. So there's some disagreement over how you treat it. Very trippy. The continuum hypothesis is essentially saying we are categorizing infinities. Is this type of infinity that we know the second smallest type of infinity? And so it's kind of like, is there an infinity between this smallest one and this other one, or is it the second smallest infinity? Sounds trippy, but we'll go into that more when we do episodes later, grade -2 or -3, when we talk about infinite-esque numbers, transfinite numbers, large cardinals, and strange things like that. Someone wondered why there's 24 hours in a day or 60 minutes in an hour. Here's the thing. I personally will make suggestions in the future for better ways we could have cut it, but they wouldn't be that different. So better ways to cut it would be, in my opinion, we should have picked the same amount of number for days, minutes, and hours. We should have had it be like 30 hours in a day, 30 minutes in an hour, and 30 seconds in a minute, or something like that. A second is an arbitrary time. We can choose how long it is. I think it would be better if it was the same span, especially if we had 30-day months, and then we had 30 hours in a day, 30 minutes in an hour, 30 seconds in a minute. That'd be pretty dope. But we don't, or switch to base 6 and have 36, 36, 36, 36. When we switch to base 6, that'll look like 100. When we switch to base 6, that'll move the decimal point 2 places. So, yeah, maybe 36. I'll come up with my own suggestions when I think through that more, but I think having them all be the same would be good. However, there is logic. The logic is that those are super divisible numbers. 24 and 60 are both on this list called highly composite numbers. And you should look back at one of the first combo class episodes on the main channel which is called Why the Number 1,081,080, or no, Why the Number 1 Million should be 1 million, what is it? 1,081,080. And that's about highly composite numbers, which will come back in future episodes because I love them. And 24 and 60 are both numbers that, for their size, are more divisible than any smaller number. And in fact, let me pull up the list of highly composites, and I think there's none even... Is there any even in between those? Yeah, there's a few. So 36 and 48 are also highly composite in between those. But essentially, you'd want a number that's like the most divisible for its size is useful, because if you're going up to that size, why not pick the most divisible up to there? Meaning you'd want one off this highly composite list, which goes 1, 2, 4, 6, 12, 24, 36, 48, 60, 120, 180, 240, 360, 720, etc. And the highly composite list contains all those numbers that you'd want to put on clocks and calendars. Speaking of which, this Friday, we have a main channel episode about calendars coming. It might be the longest episode on the main channel yet, because it ends up including a lot of roasting of the current calendar system and a lot of presentations of alternate calendar systems, and just a lot of random facts. So, and everyone, no spamming, remember. We got one of the same comment per person. You're all good. But yeah, one of the same comment per person. And then if anyone wants, if they have a different thought, they can leave a different thought or a few. I put a delay on 5 seconds for between comments. So if people spam too much, I'm going to have to up that delay. So it's like more than the 5 or 10 seconds it is right now. But I like the idea of people being able to leave a few comments somewhat in a row. So I have some trust for you guys. I might try and find a moderator for the streams when I go to a steady schedule, but I stream so randomly now that I can't really ask anyone to moderate because I just like pick a random time to do it. But when I do like a steady schedule, maybe I'll see if one of my viewers who I'm closer with would want to moderate the streams. And someone's saying there's also ultra highly composite. I think you mean superior highly composite numbers, but yeah, so the name was slightly wrong. They're called superior, but those are... The thing about superior highly composite numbers is that they have a less simply fun definition. The definition is in the form of an equation, as opposed to just being the most divisible for its size. So highly composite numbers are a slightly more elegant definition, but it's a larger club. So superior highly composites, which restrict it in a more equation-like way, those do have a more restricted list of like the super divisible. If you want to know like the most divisible number for its size with a singular amount of prime factors, like I want to know the number with 5 prime factors that is hyper divisible for its size, then I might want to pick and choose from the superior highly composite, and only one of those will have 5 prime factors, which we can see. Let me pull it up right here. The most divisible number for its size with 5 prime factors is 120. Love that number, the long 100. We are going to make, maybe, I might have to make a whole episode about the, well, here's what's going to happen. I had a thought about half a year ago that has returned in my head. So I've been wanting to finish some fiction books that I've been working on writing for a long time. I've also been wanting to write some math books. I want to make math books that are in the form of a choose-your-own-adventure, too. Not that you pick the plot, but that you get to go where you want and see how the topics connect in the order you choose. And so I have a lot of topics I want to write math books about someday, in addition to my fiction books. But there's one topic that stuck in my head, which was like, what if I wrote a whole book about threvens and throds, which is my silly nickname. I'm not going to say mine, because a lot of people through history, I'm sure, have used it. I'm sure I'm not the first person who that came in their head. But threven, being a multiple of 3, is a word I really want to get in the dictionary. That's a combo class quest. We need to get that in the dictionary during grade -2 or -3. I will start a petition when the time is right. And really, more than a petition, you need to have articles written that use the word threeven. If anyone's a journalist or knows any journalists, you need to have them write some cool articles that use the words combo class, demotro, and threeven. And then once they're in a few articles, we can make Wikipedia pages about them, and they'll have citations. And then once they have Wikipedia pages, the dictionary might be convincible. So, basically, threevens, I was one time, like half a year ago, like, what if I read a whole book about it? Just about threevens and throds. Sounds too absurdly simple to write a whole book about. How could you do that? And I thought it was just a silly thought. Like, if I did that, it would be a book with a lot of filler or a lot of random philosophy or stuff mixed in. But then I started researching threeven numbers, and I found more and more cool things about them. Also about evens and odds. And then I realized this was part of what made me fall in love with the number 6. There are so many cool patterns with evens and odds. Then there are some hidden patterns that threevens and throds have that are almost as epic as the even and odd patterns. And so when you combine those two, to look at the cycle of evenness and threevenness is a 6 cycle, a mod 6 loop. And so it made me fall in love with the number 6 and base 6 and stuff. And so in the threeven book, 3 isn't the hero, really. 6 is kind of the hero, because that's even and threeven. But it came back to me the other day that, like, maybe I will actually do the absurd task of writing a whole book about threevens and throds, because I literally have a book or more worth. I'll have to cut stuff from my notes. I, like, literally can't fit all my notes about threevens in just one book. Also, I might have to split it because I had so many notes about triangles. And triangles are more about the number 3 than about threevenness in general. Like, 21's a threeven number, but has less triangular traits than the number 3. Although triangles have a lot to do with 6s too. But triangles might have to be their own book that I thought would be funny if I write a book that's titled that it's a tetrahedron. Because tetrahedrons are made up of a bunch of triangles, and my book, though, is the tetrahedron, would have a bunch of chapters about different triangles. So it would be sort of a metaphysical tetrahedron, a stack of triangles. But that might have to be separate, because there's enough notes about threeven numbers that I don't even know if the triangle chapter will fit. We'll also see a lot about what I call pure threevens, or the powers of 3. Numbers whose only prime factors are 3s. So pure threevens, also known as powers of 3, have a lot of cool stuff too. They're going to show up in this episode about this really fun thing called the integer complexity before long. Now let me go back between a few of the comments, but let's also appreciate that although it's really foggy and we're not going to see like a massive cool colored sunrise, we are starting to get some background light. So let's see, going through some comments. Do I like the Gregorian calendar? Not really. Wait until this Friday. My Friday the 13th episode will have a lot of funny reasons I don't like the Gregorian calendar, and a suggestion for a different calendar we should switch to. 108 someone said made it into interesting pockets in ancient cultures and religions because it's super divisible. It's also, I think it's 1 to the first power times 2 to the second power times 3 to the third power, which is kind of neat, Why does 0 divided anything not equal infinity? Look at this shorts page on here. Ironically, that's like my most popular short on here of all time, is why we can't just say 1 divided by 0 is straight up infinity. Spoiler alert, it has traits of infinity and traits of negative infinity. So hello to everyone, and thank you for all the comments. I'm not going to be able to answer all of them, but I definitely appreciate them all. And also, another thing I didn't talk about as much in that video is if we just decided to say 1 divided by 0 is infinity, Then what about 2 divided by 0? Well, if 2 divided by 0 is also infinity, then we're going to start coming to the conclusion 1 equals 2, unless we remove some of the typical rules that follow for arithmetic. So if we let in the idea that 1 divided by 0 is infinity, well, now we have to remove ideas like if a divided by x equals b divided by x, then a equals b. That should be a rule, but we'd have to remove that rule if 1 divided by 0 is infinity, because what about 2 divided by 0? What about the assertion 37 and 73 are the two best numbers? Inverses and their prime spots are inverses, also in binary. Not the coolest, just because they do that in binary and in base 10. It's kind of a base 10-y trait. Humans just happen to count in base 10. So I'm not as interested in a base-dependent trait, unless it's a base-dependent trait about a wide spread of numbers. Like there was one number like 120 or something that... Let me see if this was the one I was thinking of. 120 has... in base... Nah, this wasn't the one. But there was some cool number I read about that was like divisible by the sum of its digits in all the bases 2 through 10. That showed up in a stream not that long ago. And so that was interesting because it was such a wide spread of bases. But yeah, there's a lot of cool numbers. Combo class, our current... If we need to stand by one number or have one number's back in a fight, it's going to be 6, because right now I'm going with that's the most underrated number. I think that there are more powerful numbers than 6, like 1 and 0, but stuff like 1 and 0 and -1 and 1/2 and I and pi and e and the golden ratio, those are top tier numbers, but they get a lot of credit. 6, I think, has the most discrepancy between the credit it's given and its value. Another one we really like is 120, the long 100. That is incredible. Someone asked who's my favorite Indian mathematician, and remember not to spam it. So I noticed the first time you said it because I went through the comments, so I don't need to see it a bunch of times. But I don't know a huge amount of Indian mathematicians, but of the ones I know, my favorite is Ramanujan, a brilliant mathematician. And Srinivasa, which I'm probably pronouncing wrong, Ramanujan, was a super innovative, unique thinker, didn't have formal training in the way a lot of mathematicians do, figured out a lot of his results from scratch, and then came to some brilliant, ahead-of-their-time discoveries that were so brilliant and unique that a lot of mathematicians didn't even recognize them as true or possible because they were so weird-looking, like these crazy formulas that equal pi and stuff. And they turned out to be true, most of his results, and so he's a brilliant thinker. We're still finding new consequences of his results that are good, and he has some relationships to the combo class model, because I sometimes recommend non-formal training to build unique thoughts that are different than the current structure, and I have a very unconventional way of studying sometimes, and an unconventional way of teaching. And so I think that I believe there's some correlation to, although you can't skip your formal training and hope to be a Ramanujan, you might need a few Ramanujans in society where maybe the people who did get all the formal training wouldn't have come to that really obscure conclusion that he can come to. So yeah, we'll talk more about him at some time. He died way too young, unfortunately, but found a lot of stuff before that. Someone said that the radical, when I point out the radical sign, only indicates a positive square root. Now, you'd have to be careful because the radical sign can indicate what's known as like the principal square root. So in the case of the ones you're used to, the positive is the principal and the negative isn't. But if you were doing like weird complex square roots, then you kind of need to know which one's known as the principal square root.
that it's referring to. If you want to indicate positive and negative roots, you could put a plus or minus in front. So that's a valid symbol to say plus or minus square root of 4. That gives me 2 or negative 2. Another way to do it is just say, what are the x's where x squared equals 4? As a form of a polynomial, it refers to both. So, and yep, we got some more Ramanujan fans in the comments, which is good. He is awesome. Some of my other favorite mathematicians who have another one who had a slightly unconventional way of going about some things is John Conway. And he liked playing with games, and he would find a lot of math behind the games he'd invent. And I relate to some of the ways he thought, and he came to some brilliant conclusions and brilliant findings by playing around with games and just thinking about numbers and questions in different ways. So those are some of my favorites because they are not only great discoverers and great historically, but they have some relationships to the combo class model. And then, however, the greatest mathematician of all time is the great Euler, Euler, but pronounced more like Euler. And yeah, his name is over everything for a reason. Greatest mathematician yet. What do I think of our clock system? Someone says that it should be an 11-hour system. It could assert the quarter of a day. That's weird. 11 hours wouldn't be a quarter of a day. Oh, no, quarter day of a year. 12-hour format. I'm not sure what you mean by that. The clock system, I don't think we should have the clock be 12 and the day be 24. I think the clock should be what the day is. I think the clocks should range from 0 to 23. If we want them to go AM, PM, that's okay. They should range from 0 to 11. So I'm okay with 12 or 24. But it shouldn't end with the largest number. It should go to 0 up to the number under that. Because the range we have cut out on a typical clock is from 1 to 1259.999999. 1259.999999 is basically about to hit 13, meaning 13, when we hit that, we go to 1 instead. Why does our clock range from 1 to about to be 13? Why not 0 to about to be 12? Our clock would actually go up to 12 if the largest number was 11, and then when you get to like 1159.999999, 12 equals 0. So there's a lot of improvements we could make on the clock. However, the numbers 12 and 24 I am a fan of. So, someone's saying a lot of prime composite is a log thing, an integer weighted sum of log primes. Interesting. Not sure exactly what you mean there, but sounds pretty cool. And Knuth, someone mentioned. Donald Knuth, amazing as well. Just the other day, I was reading some stuff that he had discovered, and he was awesome. He came up with some of the stuff that's going to be in the base 2i episode, if I'm not wrong. Let me double check that. Don Knuth is the one who proposed originally the type of base 2i system that's going to be the heart of one of the upcoming main channel episodes. So stay tuned for some knowledge that Donald Knuth helped create from what I'll do with base 2i in that episode. There's also base 1 minus I, which is kind of cool. We'll look at that one as well. Or negative 1 minus I works. And yeah, people are saying curiosity can expand the knowledge in those mathematicians. That's true. I love being curious about things. When you're curious, you're a lot happier. People like surprises and curiosity. So when I was saying earlier that I try and reset in the morning and click into a good mood instead of a grumpy one, I have a lot of hard things in my life, but I have the potential to be happy about things. So I try and click into that. And that relates to clicking into being curious about the day. when you're curious about what's going to happen in your day, it can be more interesting than when you're on such a pure schedule. Unfortunately, a lot of people are trapped on pure schedules. I have schedule-like routines. I still have private students I have to teach every week at given times. But over the course of this year, I'm hoping to transition to a slightly more risky plan of trying to just make videos in the future and write books and stuff. And hopefully, if we keep expanding our awesome combo growth that's been happening, where we're somewhere around 88888. Let's see if we've got, I don't think we're quite there yet. Where are we at in terms of combo lords on this channel? The main channel I care more about, that's at 23,000 sometime. Something. Oh yeah, but here we're at 88.7 thousand here. We're almost at 88888. So we're going to hit that before the next stream probably. 88888. And so that's awesome. If we continue that growth over the course of this year, then I definitely have a chance of switching out of my private teaching to have more time to have a steady streaming schedule, to drop a lot of episodes, a lot of bonus videos and shorts and stuff, and to finish my books and the music I make. And so, yeah, hopefully that will work out. And to anyone who wants to help support me having more time to make videos or write books, make sure to check out the Patreon. There's a variety of threeven amounts people contribute. And we have about 25 or so combo lords contributing there so far. Very helpful. So anyone else who jumps on there will get some cool bonus videos and stuff and be very thanked. Also, you get your name in descriptions of videos, and the people who are on a super high tier get their name in the credits sometimes. Not like every video, but I like to shout out my people who help. Someone says to be good at maths, you have to know how to calculate quickly, and I think I disagree. I think that you need to know how to do simple calculations quickly. You need to know how to multiply any two one-digit numbers together. You need to know how to add. You need to know how to do things like that. But I don't think you necessarily need to know 12 times 13 off the top of your head to be good at math. Sort of a misconception that math is this catalog of like memorizing larger and larger times tables, when really math does have a lot of creativity, and it's more about having these tools you use once in a while. And when you have a tool that you haven't used in a while, like remembering 12 times 13, there's not really a need for a lot of mathematicians to keep that in the front of their brain. Calculators are your friend, and as long as you're thinking along with the calculator about the heart of what it's doing, it can help you out. So I think that there's nothing wrong with being rusty at some calculations. There's a classic story of some mathematician who was like, oh yes, a prime such as 51. And a lot of people are like, oh my god, how could that smart guy have thought 51's a prime? It's not, it's 3 times 17. But it's like very relatable and understandable that you might not have memorized the entire list of two-digit primes as a mathematician who studies primes. So calculators are our friends in combo class. In fact, so I have a lot of funny stories from my past, and one of them I need to find the prop to go along with it before I tell it. Somewhere in my attic, I have this really big adding machine type calculator that you have to plug in to use and is like this big, that I stole from a storeroom from my school in 8th grade when I was 13 with my friend. We had a calculator heist, and we each stole a massive calculator that they weren't going to use for anything. It was like getting dust in a storeroom. So that will be a pretty funny story to tell you sometime when I find the actual prop that is it in my attic of the calculator heist that occurred when I was 13. And also calculators are extra, my friend, because the video where I divided by 0 I mentioned earlier, which is by far the most popular combo class video, it has 8 million views on here and 3.5 million views on TikTok or something, that maybe even 4 on there. That is for some reason the most viewed video on 2 separate apps for combo class. I'm using a calculator in that video, so that calculator definitely helped combo class out. So, uh-oh, my battery's low. So we're gonna have to go transition to my room in a moment, which is okay because I'm gonna shrink my face and look at some integer sequences. And I will let you guys stick around for that. Someone's saying if you could define a unit infinity being like an infinitesimal and stuff, you can run into problems with that still, where some systems of math do try and do that. However, like I said, when you introduce that idea that 1 divided by infinity equals any number that you're able to play with, then you have to ask what 2 divided by infinity is. And then once you start defining things, you're going to lose some rules of arithmetic that you like. So sometimes it's not worth it to say you can divide by infinity, but now half of the arithmetic rules need to have an addendum that says except for infinity or an infinitesimal. So like to make an addendum to like half of the rules just to be able to do that isn't always worth it. However, it's very interesting. We'll look someday at this model called the Riemann sphere that does have points that represent infinity. Yeah, and 1001 is divisible by 7. That's good. I saw a meme once that was like, just found out that, it was like something like the 51. It's like, just found out that 51 is a prime and I want to fucking throw up. And it's like, that's relatable. It's like, gives you almost this like nauseous, like, paradoxical feeling when you see a really primey looking number. It's like, whoa, that's actually 7 times 17 or whatever. Wheel theory, someone mentioned, is one of the models where they try and allow division by 0, that it will occur in some episode. Maybe I'll get hooked on it. Maybe in grade -2 we'll divide by 0 in every episode and lose all our rules of arithmetic, but probably not for an extended period. So still, people can feel free to always leave their ideas in here or in threads in the Discord and Patreon, because sometimes to feel out whether an idea works or not, you have to be like, well, let me try allowing division by infinity, and then I'll try some stuff and see if it works. And then you either see your limits or your possibilities or your errors or whatever. And so some of the fun of math is actually testing stuff out and finding that 2/3 of it doesn't work and trimming that and then seeing what you can do with the other third that worked. So anyone can, oh yeah, and here is the rule, and there is a Discord server. Yeah, it's in the description here, I believe. Pretty sure I put it in the description of this video. There's also a subreddit, so I'm more likely to see the posts on the subreddit probably if you really want to start a discussion thread involving me, or you have like a funny meme you want to make or something, you can put it on there. But if you just want to chat with random people, there's a lot of good of that going on in the Discord. So that's fun. And about rules in Combo Class, I think I said in an earlier episode, and I will clarify it later, we have a rule here in Combo Class, which is only break one rule at a time. Now, you're going to hit a paradox if that's the rule you break, maybe, so let's not have that be the rule you break, but you only break one rule at a time in Combo Class. So that's why, like, if one of my friends is like, what if they're filming me, and if they're like, what if I spray you in the face with a hose while this clock shatters? And I'll be like, oh, well, let's break one rule at a time. Pick whether you want to shatter the clock or spray me in the face and do one of those. Although sometimes it's fun to consciously combine them into one rule you're breaking, although it includes several. But whether you're talking legally or in terms of my classroom, it could be a good policy. Try and break one rule or law maximum at a time. That doesn't mean always be breaking one. That just means don't break two at a time or more. Doesn't mean you always have to do one. Someone wants a mathematical trick to impress their crush. I would probably skim through some of my older shorts and just a bunch of the shorts I've posted. Some of the shorts on this channel are like, look at this trick this number does. So you'll probably see, like, search under my shorts for words like trick or like something like, I don't know, stuff like that's probably even in some titles. Or you could also, some good ones are, look at a really old episode on the Combo Class main channel. That's the first full episode apart from the intro about the number 9, which is, I still have a 9 spray painted on the side of my house because of that episode. Actually, I'm going with that it's an upside down 6. Because you know how 9s look like that? I made it intending to be a 9, but now I'm calling it an upside down 6. Um, so there's that episode has some really fun tricks with the number 9. However, that's just because we count in base 10. We can't give 9 too much credit. It gets those things because it's 1 under the base we count in. So you get a lot of fun divisibility magic with the number that is 1 less than the base you count in. The number I call B minus 1 because B sometimes refers to your base. So a lot of fun mentions of different fields of math and stuff. We're going to be looking at some integer sequences. Oh, we got to do that really soon. Is my battery about to die? Okay, yeah, shoot. I'm at 3%. The lowest 3-even number. Okay, folks. I'm going to switch you onto a graph real quick. And then we can relocate to my room. So let me get a graph up real quick. That'll be fun. Okay, we're going to put a graph up real quick and then I'll run to my room. This graph is pretty simple, but here, now it looks a little more interesting. It looks pretty trippy, but here we go. You ready? All right, I'm going to relocate. All right, folks. Cool. How are you folks doing? Let me pause that for a moment. Let me make sure my screen's good. Yep. So, well, let's do one more graph. 1 second. All right, so let's put on a fun graph for a moment where I put a few examples on my phone. We're going to look at these integer sequences in a moment, but first I want to do these graphs. Oh no, first I need to plug in so we don't die. Okay. Let me see what was the cool graph I had idea. So, one of them that was fun was I was taking sine of x to this a that we'll make a slider for, plus or times, we're going to start with plus, sine of y to that a. So we're saying which points is the sine of that thing for the x coordinate to where I put a plus the sine of the y coordinate to the a less than or equal to some b. So now we add a slider for those. Here is if they're each 1. So now what we're going to do is try adjusting b first, and we get these shrinking circles. As they grow, they become a little more square. And then they go to that state. Now, let's put them at the grid at 0 and see what happens when we mutate A. We get these weird glitchy ones. some A's, it doesn't work. We might have to put A to a more integer-like step. Whoa. These are really cool. What was that? Yeah. So let's put A to step at integers. So it'll be a little less glitchy. So yeah, this is when A is 1. A is 2. A is 3. A is 4. They get crazy. It's having trouble seeing all the side bits is why those look so crazy. Now what if B was a little different? Ooh. Nope. A lot of weird states this can be in. What if B is 1? There we go. That's fun. This is how many subscribers are about to pass. 88888. Not that many 8s. Infinity, infinity, infinity. Hopefully. Someday we'll have an infinite amount of subscribers due to a paradox I'll cause. I'm going to cause some weird glitch in reality so we can have an infinite amount of subscribers. They're going to need to invent a new subscriber plaque for that one. Alright. So, that one was fun, but what if we multiply them instead? Now I'm going to see... Let's put A back to 1 and see B is doing a similar thing, but now the grid is this orientation. Now, if B is 0... Ooh, see, now we get this square-like thing. Lots of square, like, rectangles in all the directions. Ooh, we get a weird checkerboard. Someone should make a board game on this. This would be insane. All right. A lot of interesting states. What if B was a little larger? B can't be 1? It colors the whole plane, I guess. All right. So B worked better when it was smaller, but let's try a variation, which is throwing some tangents in. We're going to just set this to 1 for now, or maybe 0 worked better. We'll try 0 here. So there we're at 1. Now, what if we make one of these a tangent? Ooh. Our grids are a little different orientation. What if they're both tangents? Ooh. That's interesting. Double grid. Now, what if we add instead? Ooh, triangles. Ooh. Whoa. That's cool. It's a circle with a square cut out of it. You see that? Look, we got circles with these square things cut out of them. That's interesting. You ever want an equation that is kind of both a circle and a square at the same time? It's tan of x squared plus tan of y squared is less than or equal to 0. And if you want a weirder one, go for cubes up there. Alright, so those were cool, but that's not all the tricks I had up my sleeve. Let's take out that a in the exponent. Let's just make these squareds, to make this a little simpler for a moment. Kill this a switch. But what we're going to do is put something more interesting on this side. We're going to put, I'm going to make these signs. This is just one that I was fiddling around with earlier that was cool. Less than or equal to the sign of x is already cool. Now, my version was a little further, but this is already cool. Look at this weird world. But I actually put over sign of y here. Now look at this. Look at my puzzle pieces. This is my mutant puzzle pieces. Isn't that cool? So here's the simplest point of the mutation, around 0. As you go to the side, these puzzle pieces get weirder and weirder holes in them. They start getting like super glitched together. These ones are having trouble even seeing unless you zoom in super close. But these puzzle pieces do cool things. Ooh, yep. I love me some puzzle pieces. And now what if we, just for fun, of course, we got to make these tangents because we always got to, switch it around a bit. These are melted puzzle pieces. These puzzle pieces were too close to the oven. All right. So try some multiplication instead. Always fun to just fiddle around with our different variations we could have had. Ooh. Lots of types of puzzle piece you could get there. Now we're going to try another one, which is, let's put this into sine of, we'll try times, but I think plus will be cooler. This is pretty cool though, Ripley. But we're going to try plus here. Ooh, crazy stripes. Now, let's try, well, first we have to replace these with tangents, just for fun. Ooh, and then we're going to try dividing this side. Ooh, this might be a little too crazy with the tangents, so we're going to sign them out. Ooh. And, ooh, a lot of possibilities. Now, what if we put this one divided by? Sine of, oh no, x over y. Ooh. But let's make these guys tangents. Trippy. I like doing these inequalities because they're fun. Another one we'll try right here is, this is a slight variation. What if on this side I put the tangent of sine of x plus the cosine of y? And I'm going to say it's greater than or equal to the tangent of the sine. This sounds random, but watch this. We get these weird dots in the middle of this crazy maze. Look at these circles that are on and off. It's like you cut circles out of this part. Cut a circle out of there and put it there. So that's pretty neat. I haven't been looking at the comments, by the way. I'm going to have to go back to those in a minute because I do like chatting with you guys. But let me do one or two variations on this first. Of course, we got to try replacing things with tangents. Although it gets a little crazy a little quick when you have enough of those. Here we have a couple fun mazes. And where's the other ones where it punched a hole out of the thing? Those were fun. Ooh, these are kind of missing their hole. Okay. Yeah, this is another one of those hole punched out ones. Very strange. How'd these change it? Ooh, yeah. Holes punched out of this pattern. That's pretty cool. Alright, those are fun. Now for one last thing, here's a preview of something we'll try more in the future. We haven't tried many square roots. That's y equals the square root of sine of x. But what if we want the square root of the sine of y to equal the square root of the sine of x? I get x's. Look. It's like, you want to sine an x? Well, there you go. We signed an x. So that's interesting. When you do variations on this, you get different spread out little shapes. Here we get these fellas. Here we get those fellas. If we stick a variable in there, we can sort of move them or make them dance a bit. Let's put the variable on both, and now they're sort of moving. Are they just like moving to the side? Where are they going? That's weird. It just depends on if it's positive or negative or something for that. Tan of A. Tan of X. Tan of X equals tan of A. Oop. All right, that just scales them. Okay, so that's just a little preview of what we might try in the future. You know, sticking some like weird fellows like this. Whoa, now they have little hats on them. Whoa, these hats are very dense. These hats have maybe an infinite amount going on in them. That's trippy. Um, Ooh, look, we get all these arrows, and when you zoom into an arrow, it's this like infinitely dense arrow. Look, we can go down the arrow tip. Oh my god. Cool. If anyone's good at getting really good like footage of any of these graphs, zooming in or out, hit me up because I might want to use some footage of these wild fellas in an episode someday. Viewers can always remember I'm still building my team, and anyone who wants to find a way to help out, if you have some skill or are just a big fan, can always hit up me from the contact link on the page if you're actually helping out in some way and not just if you want to just say hi, just do that in a comment. So although I am slow on getting back to some emails because it's been busy, today after this I have a doctor appointment, and then I am filming the rest of my calendar episode, and it's going to be raining, so it might be another episode that half of it takes place on the porch. So there I am back there. And the other thing I wanted to check out was this online encyclopedia of integer sequences. So we're going to switch off Desmos for the rest of the stream. We're going to do a little mathy stuff. And it's mostly going to be a preview of a new cool feature that I noticed. I don't know if it's new for them, but I didn't know about it. Where we can go to this thing called webcam there. And I'll show you what that does in a minute. First, let's just say, what is this thing? It's an online encyclopedia of integer sequences, strings of whole numbers that follow some pattern or rule. And it's very useful. Let's say I was curious, is there a pattern behind how many prime factors each number has as I go up the number line? Well, let's see. 0 has no prime factors. 2 and 3 have one prime factor. I'm typing these in as we go. The fourth term, if I'm talking about 4, has 2 prime factors. 5 has 1. 6 has 2. And let's see, now search, does this come up with anything? It does. Number of prime divisors of n counted with multiplicity. That means like in 4, I counted both of the 2's that make up 4. Now here we see they have nicknames for it, and we have facts about it here. We have conjectures as well as facts. So the Encyclopedia of Integer Sequences is super cool. We also have lists. So look, table of it up to 100,000, is that it? So if I needed to know how many prime factors does 100,000 have? Well, it only has 10 prime factors because it's kind of an overrated number. But if we go to, let's go to a really divisible number. We'll go to 5,040. And we're going to see the highly composites might stand out a little more. Not necessarily just highly composite because we're just looking at prime factors. It only had 8 prime factors. So yeah, the ones with more prime factors for their size, I guess, would be powers of 2. So, yep. Powers of 2 will probably pop out of that list because they get their prime factors quicker if you're counting multiplicity, but basically that's the OEIS, super cool. Here's this new feature I saw on it. I mean, not saying it's new for them, but that I noticed. This thing called webcam. You can select best sequences. I'm stopping it right now, but you can it reloads from some list they called best sequences every once in a while. And then I can pause it if it's one I really want to talk about. So right now, let's do 10 seconds and I'll just be ready to pause. But look, this is called Catalan's triangle, but it's read by rows, so this is a little more confusing. So we're going to see a reset when that little number goes down. And here we get the sum of the terms of composite harmonic series. Now, I'm not sure exactly what they're referring to there. Um, Number of n bead necklaces turning over is allowed where complements are equivalent. That's interesting. Um, okay, an plus the an minus 1 is supposed to be the nth prime. So, like, those add to 5, those add to 7, those add to 11. The number of magic squares you can make of order n composed of these numbers, counting rotations and reflections. So, like, magic squares are like this thing you could try and design. It looks like they don't know how many you can make with 6 for this trait, but with 5, that's how many of the thing you can make. So, pretty cool. Square array of polygonal numbers. The square arrays are a little harder to explain. Let's do when I say so. All values attained by the phi of n function, which isn't actually related to the golden ratio. The golden ratio happens to have this name, but they reuse Greek letters. This is this thing called the Euler phi function thingy that we will go into in later episodes. But there's all the values it can hit, counting multiplicity. All right, pretty random. Let's see. Number of infinitary divisors is another type of divisor we didn't talk about. We talked about this one called unitary divisors that has a different definition. But this is a whole nother story. One's called infinitary divisors. And this is how many infinitary divisors each has. So, pretty cool, all the stuff we're going to do on here, all the sequences that'll give me a chance to share some math with you guys or learn some new stuff myself. Whenever I see a sequence on here, a 50-50 chance whether it's something I know that I'll learn a little more about or something I have no idea about that will be introduced to my vocabulary. Because they have all sorts of weird, interesting sequences on here. Like, what the hell is that? I don't even know what that means. I don't know. But it says, apparently, a of n plus 1 is also the number of ways to place n non-attacking composite pieces semi-rook plus semi-bishop on an n by n board. I don't know what a semi-rook or semi-bishop is. This sounds like that Anarchy Chess subreddit is leaking out here. But nah, that's some rule they probably came up with. Yeah, that's interesting. That's one of my favorite things here when they have a list that has one definition for what the nth term is, but the comments include another definition that we could have given for what the terms are. Like, if I look up something like the powers of 2, there's like so many ways I could define this. So it's like also the number of subsets of an n set. Also, the number before 2 to the n minus 1 compositions of n. It's also the number of this and the number of that. So there's a lot of ways to define certain things. Like I could say prime numbers are the numbers with 2 divisors exactly. Or I could say prime numbers are the numbers that don't do this. Or I could say, prime numbers are the numbers whose proper divisors add to 1. Or a lot of ways I could define stuff. So I'm going to go back and see if there's any comments to chat with. As usual, I'm not going to be able to answer all of them, but I love them. So you all are awesome combo lords. And let's see. Is Desmos much better than GeoGebra? I don't know. I don't think so. I haven't tested out GeoGebra. I think once I test out GeoGebra, there's a chance I'll switch to it. I think there's a chance it's better. So I'll try that out someday. I don't like learning new technology stuff. I need a tech guy on my team. So when I learn a technology, I'll have plenty of fun with it if it suits my mathematical or artistic needs. Like, I got good at using cameras, I got good at using microphones, I got good at using certain things. But, like, the beginning to figure out GeoGebra will be really annoying to me, so I want someone to just, like, sit down and show me the basics someday, and then I'll probably have a lot of fun with it and do it on some streams. I've seen cool stuff on it that Desmos couldn't do. We do have some suggestions for other ones they wanted me to put on Desmos, but sorry, I am not able to test out any Desmos right now. I gotta go pretty soon. And yes, it does relate to the totient function. And yeah, a lot of cool stuff. So you could find many ways to find stuff. Like someone mentioned a factorial randomly. If we look up the factorials, then we would find that. And we would see some facts too. Look, earliest publication that discusses this appears to be that. And they said, see this book by Newth, who we talked about earlier today. And yeah, there's a lot of ways of defining the factorials. I mean, the simplest is factorials can be defined as the number of permutations of n things. Or they can be defined as this multiplicative thing. They also can be defined in group theory, the order of symmetric group S of n. So we haven't done a group theory lesson yet, but we will someday. It's a magnificent large-scale field that is sort of an underpinning behind many other fields. So let's go back to one or two more randoms. Greatest common divisor of n factorial and n to the n. That's interesting. So like, what's the biggest factor in common that 5 factorial and 5 to the 5th power have? Just 5. But 6 factorial and 6 to the 6th power have 144 in common. Oh, it's going. So there. Okay, we're on to some new ones. I'm gonna just do one or two more. A lot of graph ones. A lot of fun things we'll talk about here. I think I gotta go soon on the stream. Let's see. I think that's going to be all for our stream today. Leave any last thoughts or questions in the comments if you want. After this, I got to do a doctor appointment. Then I get a more fun part of the day where I get to film with a camera person who I'm hiring, my friend Carlo, about calendars and try and dodge the rain and maybe lightning based on the forecast. And then I have to teach private lessons. So it'll be busy. Maybe if I have time, maybe I'll film a short video with Carlo to upload a short on this channel later. Probably also find a way to film a little bonus thing for my Patreon people, to any of you who are on there. I'll have some more cool bonus ones coming soon. For example, like, there's a bunch of extra bubble footage from my last bubble video, so maybe I'll put some behind the scenes of generating bubbles on the Patreon. So, thank you all for joining me, and thank you to anyone who watches this in the future. And let me think about, on my own, what I'm able to upload for you guys later today, but there will probably be some sort of short or something on this channel. And stay tuned for a really cool episode this Friday about calendars on the main channel. I'm putting it out on that day on purpose because it relates to Friday the 13th. Some people think that's a superstitious day, but if you watch my episode that drops that day, you'll have a lucky day. So, love you all so much. Have a great one, and I will